Okay, so good afternoon, ladies and gentlemen. My name is Chu Yan. I'm from National Taiwan University of Science and Technology, Taipei, Taiwan. Today, my topic is a compact event transition from rectangular waveguide to substrate integrated waveguide. And here's the outline. First of all, I will introduce the motivation of the transition design, and then I will show my transition design and simulated result. And finally, I will end with the brief conclusion. Okay, so let's get started. Because the terahertz signal is commonly generated by the frequency extension module, as the figure you can see right here, we will use the frequency multiplier to multiply a relatively low gigahertz signal up to terahertz, and then connect to a conventional waveguide at the output of the multiplier. Also, as the input signal of the terahertz component as this figure. So the first reason we designed the transition is because the terahertz frequency extension module, its multiplier, the interface is waveguide. And the second reason is there are no commercial high frequency coaxial cable and connector that we could use at terahertz due to the mechanical difficulty. So as these two reasons, a proper transition between a waveguide and a PCB or chip at terahertz would be an issue worth investigating. So let's talk about the transition design. This is the single transition design, and because our center frequency is at 150 GHz, we use WR06 as our desired waveguide. And Figure 1AB shows the geometry of the proposed transition. As you can see, the transition primarily uses an aperture-coupled patch antenna, which is placed at a distance of quarter wavelength on the short circuit end of the SIW to create an open circuit boundary right at the center. And we face the surrounding slot to transform the T10 mode from the W06 to the SIW smoothly on the printed circuit board. The design is fabricated on 10mm Rogers RT Duroid by W80 substrate. And here's the tab to summarize the physical dimension of the proposed design. Also, taking the PCB design rule into account from my design experience, the value L1 is set to 0.17 mm as the limitation. An even smaller value of L1 could further enhance the coupling strength and therefore result in wider S11 bandwidth. So a higher resolution process is needed for terahertz circuit transition design. Here's the response of the single transition design, and Figure 2 and 3 show the electric field distribution at 150 GHz. From the cross-section, we can see that the T10 mode is transferred from the vertical W06 section to SIW to the horizontal SIW smoothly, and this could show the validation of the design concept. And Figure 4 shows the fractional bandwidth with SM11, which is less than minus 10 dB, is 14%, and the insertion loss is 0.7 dB and 150 GHz. Okay. So as you can see, the Figure 5 shows the back-to-back transition configuration for validation. A good contact alignment between the W06 and PCB. Therefore, screws are used and the H-band is designed to roll bypass the screw holes. And the flange UG3A7 has a diameter of 19 mm, which sets the minimum transmission distance of the back-to-back transition. And this distance is greater than 10 guided wavelengths, which explains the high insertion loss of 1.42 dB at 150 GHz as shown in the Figure 7. And also the simulated fractional bandwidth of S11, which is less than minus 10 dB, is 9% from 143 GHz to 157 GHz. And here's the electric field distribution at 150 GHz of the back-to-back transition. Okay. So let's make a brief conclusion. Due to the frequency extension module of terahertz equipment, there is no high frequency coaxial cable and connector. So the waveguide to PCB or chip transition is necessary at terahertz band. And the second thing is that as the frequency rises up to the terahertz band, the wavelength becomes relatively short. It means the designable area is very limited, especially it would be challenging for modern PCB process. Therefore, high resolution process is needed for terahertz circuit design, and it will remain a future topic on how to design a high performance circuit using low cost compact PCB process at terahertz band. Okay, so I hope you have a good understanding of my presentation. Thank you for your attention.